Hello students, hope you're all doing good. So this video is powered by Synthesis Tutorials. So in today's video we'll be starting with a new chapter, that is chapter number 12, which happens to be reflection. So in this chapter is the first chapter of the unit coordinate geometry. So in this chapter, as the topic suggests, we'll be talking about reflection. So you all know that reflection is actually a property of a mirror. So here we'll be seeing that how a point is it's not being reflected, but if it is being reflected at certain surfaces, then how can we visualize those points? Alright, so to begin with, we'll just discuss what are the coordinate axes, which you have read already, children. So if you just see, this is our x-axis, this is y-axis, this is called y dash, this is x, and this is x dash. So these things you know already. This is a Cartesian plane, and this is called positive x-axis, x dash is negative x-axis. The upper part y is positive y-axis and the lower part is negative x-axis, sorry, y-axis. Now what you need to know, children, see, this is the next thing is when we talk about coordinates. So that also you know that how we denote the coordinates. So the point which is the x, we always denote a point y by this particular pair of two numbers, that is x and y. So wherein x gives what, the x coordinate, and it is also called by the name, if you all remember, it is called abscissa. Okay, so this is called abscissa, and this y denotes what? It denotes y coordinate, which is also called normal ordinate. Okay, so this is abscissa and this is ordinate. So these are the two names that we consider. So if you remember, whenever we have a point over here, suppose the coordinates of this particular point are 3, 4, then for this, the particular, this x is, the 3 is called x coordinate and 4 is called y coordinate. So this is the thing which you have studied already. So I just wanted to revise these points. So since we are done with this now, so what is important, children, for here, you need to know that in the questions also they can be asking that what will be the reflection of abscissa or ordinate. So you need to remember that the first one is called abscissa and the second one is called ordinate. So this is an important thing that you should remember. Now what we'll be doing, we'll be moving to the next part, wherein we'll be seeing what the thing which is new in this chapter. So this particular thing is called reflection. So I'll be just writing down here reflection. Okay, so what is the general meaning of reflection, children? That whenever an object is placed before a plane mirror, the image formed is at a same distance behind the mirror as the object is in front. So suppose this is the plane mirror which I am taking. Suppose there is a point A which is at a distance of suppose 10 centimeter. Then you always know that whenever its image is formed, it will always be, suppose this is A dash and the distance is going to be same. That is the characteristic of a plane mirror. Okay, so therefore to find the image of a point in any line, so consider we have this particular line PQ as a plane mirror, and there is a point A which is an object and A dash is its image. Now what happens, children, you will always notice that this particular distance is going to be same as this. Okay, so this is the normal thing. And if you look into the figure that has been given, so in this figure, okay, so suppose I have taken a point P. To find the image of this point P, so suppose this is my line AB, so we have to consider AB as a plane mirror. Okay, so what we are doing now, till now we were discussing about plane mirror, and now the same situation we are taking in terms of graph. So here they have imagined this AB as a plane mirror. Now if suppose this is P point XY in this side, then of course whenever I am getting an image on this side, this will be called P dash, and the coordinates of this point will be X dash and Y dash. Why X dash Y dash, children? Because the point is getting reflected. Okay, and the distance between both of them is going to remain the same. Suppose if this is A units, then this is also going to be A units. Okay, so now what happens, this point, that is P dash, is called the image of point P. So you can clearly see that this particular point, that is P dash, that is called image of point P in the line AB, and line AB, which is also perpendicular bisector of PP dash, is said to be mirror line or the mediator. So you can clearly see, children, that whenever you are joining this both points P and P dash, okay, so this particular line, that is AB, which is supposed to act as a mirror, this is actually acting as a perpendicular bisector of this line P dash. Now why perpendicular bisector, children? Because clearly you can see this is at a right angle. And why bisector? Because we know that this distance is always equals to this distance. So this is a perpendicular bisector. Now this line AB is called mirror line. Okay, so these are the names which are there, children. So this is called mirror line, and this is also called what? Mediator. So this is mirror line or mediator for which particular segment, children? This is for line segment PP dash. Okay, so whichever mirror which is just acting, not mirrors exactly, children, whichever line which is there, which is acting as a mirror for a particular point, is called a mirror line, or else it is also called a mediator. So this is the thing. Now the transformation which maps a point P to P dash is called reflection. Okay, so whatever I am getting for this point, suppose I am getting an image over here at an equal distance, so this process is called reflection. Now one more thing, children, that you need to know is that how do we denote this particular process of reflection. So whenever we write, so we always write reflection in this term, children. This is M, which M is denoting the reflection, and we'll be subscripting L here. So what is L? L is the line or a point at which the reflection is taking place. Okay, so this is the nomenclature, children. This is the way you are denoting, not the nomenclature. So this is capital L, and then we'll having a subscript as small l. Now what is L? L is the line in which the reflection is taking place. So if you just consider this particular figure, you can see, so how can reflection be denoted as M, and in the subscript you can be writing AB, because the reflection is taking place along AB. Okay, so now if you talk about general terms, children, so suppose there are three cases which are there. Okay, so suppose I am writing here reflection. Okay, and here I'll be writing how it is representation. So if the reflection is taken along x-axis, children, then it is denoted by what? M along x-axis. If it is reflecting along y-axis, okay, then we denote it as M, and in the subscript y. And then if it is reflecting along origin, then it is called what? M, and the subscript I'll be writing O. So these are the three cases, children, that we'll be considering in this particular chapter, and then we'll be looking into that how is reflection taking place in each of them. So as of now, you must be knowing that this is the way that you denote this particular reflections. Now one by one we'll be moving that how is reflection taking at x-axis, at y-axis and origin. So we'll be starting with x-axis. So this is the thing which is there in your textbook, children. If you can just look, this is in page number 163. So reflection in the y is equal to 0. So these are the terms which are there, children. So you already know that when y is equal to 0 means the point lies on x-axis. So if the question is asking for y is equal to 0, or if it is asking that the reflection in the line in x-axis, one or the other, they are going to be the same thing. And then how is this happening, children? See, suppose this is my Cartesian plane which is there, and now what I am saying, that reflection is in the x-axis, means what, children? This particular x-axis is acting as a mirror. So suppose I have a point which is P, which is x comma y. Now if I have to reflect this particular point along x-axis, just keep this in mind, children. Just look carefully into the figure. So if I want x-axis to act as a mirror, so it is understood that, children, whatever the distance it is up to here, that particular distance it will be here as well. So what will be the reflection equal to? This will be equal to p dash. See, x coordinate is going to remain same, because whether it is on, this is your first quadrant or this is your fourth quadrant, it is always positive. So this will be positive. And then what happens to the y coordinate? In the first coordinate, if you see first quadrant, y coordinate is positive, so this is positive here, and when we talk about fourth quadrant, this becomes minus y. Okay, so basically what is happening, if the reflection is taking place along x-axis, then y coordinate changes its sign. Okay, so this is the most important thing, children, changes its sign. So what does that mean? So this means that when we say that 0.68 is getting reflected along x-axis, so this, what will be the image of the point? This will be 6, minus 8. The x coordinates will be remaining same, children. Why? Because you can clearly see here, because x is already in the positive direction, so it has to be x only. What is going in the negative direction is just y. So whenever it is on the, you have to remember, children, that whenever it is getting reflected along the x-axis, then the image will be formed where it will be formed on the fourth quadrant. Okay, and when fourth quadrant, when the point is in the first quadrant. If suppose it is on the second quadrant, then it will be found in the third quadrant. But what is important for you to remember is that the x coordinate is not going to change. What is going to change is the y coordinate. Okay, so how are we symbolically representing this? So this is being represented by mx. Okay, why mx? Because reflection is taking place along x-axis. So reflection along x-axis, if the points is x comma y, then point x remains same, y becomes minus y. Okay, so the example of this is what? Suppose reflection along x-axis to the point 2, 3, the answer will be what? 2, minus 3. And it is, if the question is along x-axis, or it is saying reflection in the line y is equal to 0, both of them are one or the other same thing. Okay, so basically if it is of the form a comma b, it will turn to the form a comma minus b, and if it is of the form a comma minus b, it will turn to a comma b. Okay, so this is what you have to remember. Means, for example, if the point is 2, minus 3, it will be turning to 2, 3. Okay, so this is the reflection. Means what is happening? The y coordinate is changing its sign. So that is the reflection along x-axis. So a simple way to remember this, children, is if the reflection is taking about x-axis, then x-axis is not changing. And similarly, if the reflection is taking place along y-axis, then the y-axis won't change. Okay, so y-axis, if the reflection is taking place, children, it is also called for the line when x is equal to 0. Okay, why? Because whenever you are taking x is equal to 0, then it means that the point is lying on the y-axis. So both of them are similar. So according to this, if you just look into the figure which is there, so suppose there is a point which lies here, that is p x comma y. So suppose that if this particular plane, that is my y-axis, is acting as a mirror, then the reflection of this point will be on this side. Okay, suppose this is the mirror, then the reflection is on this side. Now this continues to be the positive side of the y-axis, but here it is positive x-axis, and when it is going here, this becomes negative x-axis. So what do you see? That the sign of x is getting changed. Okay, so this is what is happening. So when the reflection is taking place along y-axis, it is written as what? M y x comma y will be equal to, the y-axis is not changing but the x-axis is changing, so this is minus x comma y. Okay, so therefore what is happening, when a point is reflected in the y-axis, the sign of its abscissa is going to change. Okay, so suppose we say that there is a point -5 comma -7 and it is getting reflected in the y-axis, then what will be the point, what will be the coordinates? This will become 5 and -7 because y-axis is remaining same. So if we want to talk about general terms, if the reflection is taking place along y-axis for a comma b, this will become what? -a comma b. And if it is taking such a way that the points are -a comma b, then this will become a comma b. Okay, so here what you have to see, that if a point is getting reflected along x-axis, x remains same. If it is getting reflected along y-axis, then y remains same. Okay, so this is the important thing which is there. Now we'll be looking into next thing, that is if it is being reflected in the origin. So what does this mean, children? This particularly means that suppose I have a point over here, this is being reflected along the origin, means what? There is a mirror. So there is a mirror which is passing through the origin. So suppose this is the mirror that we are talking about, then it is understood, children, that where can you expect its reflection? It will be this side, that is p x dash y dash, p dash x dash y dash. Okay, so what you can see, children, clearly here the sign of both of them is going to change. So it is on the positive side of x-axis and positive side, sorry, this is positive side of y-axis and positive side of x-axis. Now if you look into this point, this goes on negative side of x-axis and negative side of y-axis as well. So basically when the reflection is taking place in origin, okay, so now what is happening, suppose I have a point, so I'll be noting this by MO. So if it is x comma y, then the symbol of both of them is going to change. If I want to give you example for this, this can go like this. Suppose -6 5, if it is going along the reflection of the origin, then this will become 6 comma -5. So basically what is happening, the symbol of the both the coordinates is changing. Okay, so if I just want to display this in short, so suppose I'll be writing like this, I'll be making a short table here. So this is point and this is reflection, and reflection of what? When it is taking place along the origin. Okay, so suppose I have a point that is AB, so upon reflection it will become -a comma -b. Suppose I have a point that is A minus B, so upon reflection it will become -a comma b. So what you can see, that all the coordinates are just getting reversed. So this becomes A comma -b, and at last if I am having -a minus b, then the coordinates are becoming what? A comma b. Okay, so this is what is happening when it is getting reflection in the origin. So this is the easiest one, children. So whenever in the question it is asked that what happens when the reflection takes place in the origin, then you can easily just revert the symbol of both the points which are there. Now to revise these things, children, if you just look into it, what we can say, see, we can just say it like this, that there are three things which are happening. Okay, so one is when the reflection is taking place upon x-axis, and then when it is taking place upon y-axis, and when it is taking place along origin. Okay, so x-axis can also be called as when y is equal to 0. So because in the question, children, you have been given this as well, okay, that y is equal to 0, and in y-axis this can be written as x is equal to 0, and origin, of course, the point will be 0 comma 0. Okay, so you can be looking for these things, children, because in the question they have given y is equal to 0 as well. So you'll have to look into both the things. Okay, so when it is taking place along x-axis, what is happening, children? You will see that abscissa remains same. Okay, so basically if the point is x comma y, then what is the reflection? It is x comma minus y, that is the y is getting changed. Okay, so here what is happening, if it is in y-axis, then ordinate remains same. and abscissa is changing. So the point, if it is x comma y, then upon reflection this is becoming minus x comma y. And if it is in the origin, what you will be writing, both abscissa and ordinate changes. Okay. So how can this be explained, children? This can be explained as, suppose the point is a comma b, sorry, x comma y, then the coordinates become what? The coordinates become minus x comma minus y. Okay. So these are the things which you are getting. And now what we can do, we'll just see one more thing which is there, children, which is called invariant point. So as the name suggests, children, that what is invariant? Invariant means any point which is invariant. In simple English is a term which means that it is not getting altered, or it is unaltered, or it's not getting affected, it's not getting variated. Okay, so as the name suggests, what is invariant point? That any point which is not undergoing any transformation, children, or it is not getting any affected even upon reflection, is called an invariant. Okay, so what can be, if you see, children, suppose I take a point over here, suppose this is my point. So since it's lied on x-axis, the coordinates of this point will be x comma 0. So if suppose it is getting reflected along x-axis only, then what will be the coordinates of this point, children? Of course it will be x comma 0 only, because it is getting reflected along x-axis only. So this point will be called invariant when the x-axis is acting as a mirror. If it is reflected along x-axis, if it is reflected along y-axis, then what about its coordinates, children? This will become minus x comma 0. This you know already. But if it is getting reflected along x-axis, since it is, the point lies on the axis, so there is no alteration, so this is called invariant point. So similarly, if I have a point which lies on y-axis, children, so suppose this point is 0 comma y. So if I want to say that what happens when it undergoes reflection along y-axis, so you clearly know that this only is your y-axis. So how can a point undergo reflection along this, since it lies on this? So your answer will be 0 comma y, and you will be calling this particular point as invariant. Okay, so what you can say, that whenever we have a point on an x-axis and it is getting reflected along x-axis, then that particular point will be called invariant. And whenever we have a point on the y-axis and it is getting reflected along y-axis, then that particular point will be called invariant. And what about the case of origin, children? Clearly for the origin, I have a point 0 comma 0. Okay, this point will be invariant, because if my mirror passes through here, my point is already here. So this is acting as invariant. Okay, so for example, that has been given in your textbook. So suppose I want to say that minus 3 comma 0, it is acting as an invariant if it is undergoing reflection in the x-axis. And if I talk about the point 0 comma 15, so this is called invariant if it is going reflection along y-axis. Okay, so these are the theoretical parts which are there, children, in this chapter. Now since we are done with the explanation part, we will be moving to the exercise. Okay, so we'll be looking into few sums. So this is our exercise 12a. Okay, so if you just look into question number 1, children, it is sort of completing the table. So this you can be easily taking as homework. Why? Because I'll be telling you how to do. See, the first one is, see, you have been given a point over here. Okay, and then you have been given transformation, means what is the change that is happening, and then you have been given image. Okay, so the first point is 5 comma minus 7. Okay, and the image has been given as minus 5 comma 7. So clearly you can see, children, that the signs of both of them are getting changed. So what can be your answer? Your answer will be it is reflection in what, children? It is the reflection along origin, because the symbols of both of them are getting changed. So what you will be writing? You will be writing reflection in origin. Okay, so this is how you are going to fill the box. So first one I have done, second one I'll be telling you how to do, and then C, D and E you will be taking as homework. Okay, so if you see the B1, I have been given 4,2. So reflection on x-axis. So you already know that in x-axis, x coordinate remains same and y changes. So what will be the point? Image will equal to 4, -2. So this one is pretty easy. So you can be taking this as homework. Okay. So now we'll be moving to the second question. Second question says a point P is its own image under the reflection in a line L. So suppose I have a line L which goes like this. Okay, and there is a point P which is acting as its own image under the reflection. So describe the position. So clearly you can see here, children, if it is acting as its own reflection means this point is invariant. So when is the point invariant, children? Whenever the point lies along that axis. So it is understandable that the P should be lying along L, then only its image will be same. So what will be your answer? That the P lies on line L. Lies in, you can write, lies in point line L. And you now know the reason, children, because if I want that the reflection is my own, then I have to lie on that particular line only. Okay, so we'll be now moving to question number 3. Easy questions coming in. So this is our question number 3. So it says what, children? It says state the coordinates of the following points under reflection in x-axis. Okay, so what is my point? So I'll be doing one question, children, and then the second and third is going to be your homework. Okay, so the point has been given as 3,2. So what will be reflection, children? And it is being reflected along what? It is being reflected along x-axis. So if it is being reflected along x-axis, it is understood that x coordinate will remain same, y coordinate will change its sign. So this is 3, -2. Similarly for -5, 4, it will be -5, -4. For 0, 0, it is going to be equal to 0, 0. Okay, so now if I move to question number 4, what does this says? See, this is our question number 4. Here, state the coordinates of the following points under the reflection in y-axis. Okay, so here also I'll be doing the 1, and the second and third will be your homework. So what is my point that has been given? So you'll be writing like this point, and here you will be writing reflection. So the point that has been given is 6, -3. You have to remember, children, that since it is getting reflected along y-axis, y will remain same, x is going to change. So this will become what? -6, -3. Similarly, the second one will become what, children? -1, 0 will become what? -1 will become 1, and that's become 1, 0, and third will become what? -8 is becoming 8, and you will be writing 8, -2. Okay, so this way. Now we'll be moving to what? We'll be moving to question number 5. So question number 5 says what? State the coordinates of the following points under reflection in the origin. Okay, so for that, of course, this is also an easy one, children. Point, and here you will be writing what? Reflection. Okay, the first one I'll be doing, second and third you will be taking as homework. So if the point is -2, -4, it is understood that upon reflection this is going to be 2, 4. As easy as it can be. Okay, because when it is crossing through the origin, if the origin is acting as a reflecting surface, then the coordinates of both the points get changed. Okay, so similarly, if you see question number 6, okay, so state the coordinates of the following points under reflection, okay, of the following under reflection in the line x is equal to 0. So this is question number 6. So you already know, children, if the line is x is equal to 0, then this means what? It is actually acting as y-axis. Okay, so what is the point has been given as -6, 4. So if the point is, if y-axis is acting as mirror, then what happens to the reflection? Y coordinates remain same, x coordinates changes. So this is 6, 4. Okay, on the similar ways you will be doing 2 and 3. So for question number 2, your answer will be what? 0, 5 children. Why? Because it's already 0. Okay, so this point is acting as an invariant. And third, it will be what? -3, -4. Okay, looking on to the next question, children, that is question number 7. So in question number 7, it says state the coordinates of the points under reflection in the line y is equal to 0. So y is equal to 0 means what? The reflection is taking place along x-axis. So you already know, children, that suppose the point is -3, 0. So this point lies on x-axis. So upon reflection, this remains what? -3, 0, because x-axis is not changing and y-axis, y coordinate is already 0. So that cannot be -0. So it will be 0. Okay, so second one, it will be what? Since it is getting, so this will be 8, 5, and for the third one it will be -1, 3. Easy ones coming in, so you can be taking as homework. If you look at question number 8, okay, we'll be just looking into this. So this is my question number 8. It says what? A point P is reflected in the x-axis coordinates of is, okay, so there is a point, okay, so suppose the point is whatever, what is given is image. So this is image and this is my point. Okay, so here you can see you don't have point. The image has been given as -4, 5, and it is getting reflected along what, children? It is getting reflected in x-axis. So it is understood, children, if it is getting reflected along x-axis, x has to remain same, and this points become what? It becomes -4, -5, because this point only on reflection will be giving me -4 and 5. So that the first sub question is the coordinates of the point will be -4, -5, and the second sub question is what? That find the coordinates of the image of P under the reflection in y-axis. Okay, so what happens when it is undergoing reflection in y-axis, children? My point is what? -4, -5. So in y-axis, if it undergoes reflection, then y coordinates remain same and x coordinate changes. So what will be the sign now? If it is happening, this will be 4, -5. Okay, so the answer for second sub question will be 4, -5. Alright, so this was an easy one, children. There was a twist in this question that they had given what? They had given what first? That they had given, instead of the point, they had given the coordinates of the image. So from there you found out the point, and then that was the first sub question, and then they asked the image of that particular point on the y-axis. So in this way it had to be done. So we'll be moving to the 9th question. So 9th question says what, children? It says, see, this is question number 9, that a point P is reflected in the origin. The coordinates of the image are. So here also the same thing they are telling, children, that there is a point and then its image has been given. Okay, so if the point is -2, 7, children, it is understood that if it is origin, then it will be what? 2, -7. So this is going to be my coordinates of point P. And second, they are asking find the coordinates of image of P under reflection in y-axis. So this is my x, this is my normal point, and when, so first answer will be 2, -7, children, and when it is undergoing along y-axis, children, then what is happening? See, it is undergoing not y-axis, children, it is undergoing reflection in x-axis. Okay, so if it is undergoing reflection in x-axis, x coordinate remains same, y coordinates changes, so the point will be 2, 7. Alright, so these are the easy questions. You only need to remember that if the reflection is taking place along x-axis, x remains same. If it is taking place along y-axis, y remains same. And if origin is acting as a reflecting line, then the coordinates of both the coordinates of both the coordinates which are there, x and y, they will be changing the sign.